Hey everyone, my name is Quackmero, and today I'm going to be teaching y'all how to install Android Studio and set up your first program for FTC or your first TeleOp. First, you want to pull up Android Studio here, and you want to press download Android Studio Quill 2, and you should scroll all the way down. Have red, skip, Intel chip. This is going to be different for me since I'm doing this on the Mac and on my iMac specifically, but for y'all, if you have a Windows, it should easily just install. Okay, now that we have installed Android Studio, it should just open for me. Like, for example, open, it's opening, it's verifying. Okay. Now if I drag this here, it should start installing. Yep, just like that. It should be a little different for y'all in Windows. It should be a lot more simpler though, since it's just as simple as installing and setting up. Okay, it should be here now. Here it is, Android Studio. Okay, verifying. Okay. Okay. Now it should just pop up asking you if you want to do this. I personally don't want to send my info. Okay. You can see I already have my programs, but what you would do in this situation would first go to the official FTC GitHub, go in here, you would press on code, and you would download the zip file. You see it here? Okay. It should be this one right here. Show in Finder, okay. Now that we see it here in Finder, we're gonna unzip or okay. Now that we have it here, normally for Windows users, you would extract this file. You would extract everything in here, and you would basically go to Android Studio. Let's say open. We're going to open, and what we're going to do is go to downloads. In this case, I have it right here, FTC controller master, and I would open this file right here, FTC robot controller, not the master. Wait, oh wait, no, it is this one. Okay, you would open FTC robot controller master, open this, trust project. Okay, now you have the basic setup. Here it's gonna bring you here. What we're gonna do is wait for it to actually analyze everything. You just give it a couple minutes and you'll see what I mean. It's syncing to the Gradle in this case, but we just have to wait for it to do this process. I'll go back to you and show you how it should end up looking like. Just wait like 5 minutes. It should be done pretty quickly. Okay everyone, so once Android Studio has downloaded and has been set up now, or is this okay everyone, once Android Studio has analyzed and opened up and synced with the Gradle, open team code, open Java, and here org.firstinspires.ftc.teamcode represents a folder that will hold all of our code. All of our code is going to go inside of here. So we're going to right click, go on new, hover to Java class, and we're going to name our class TeleOp. This will basically serve as our code that will program the robot to move, right? So follow with me. Just type extends op mode, right? Okay. Now op mode. Oh wait. Sorry, we have to put at TeleOp. Oh, there's an error. What's the error? Oh, okay. Sorry. I think we went too much forward. Okay, op mode has two essential functions: the init function, public void init. The init function basically tells the brain of the robot, the control hub, what the motors in the program corresponding to those in the physical robot. We will also do some minor but important changes, such as reversing motors permanently inside of the init function. Now, we also have the public void loop. We call this the loop function. The loop function basically is its name. It loops about 40 to 60 times a second because it's trying to check for user input through a controller or sensor to perform a sort of movement or action, like if we were to move a controller joystick to move a robot upwards or backwards. Now, we're gonna go back right here. Now that we have those two things, I feel like we can actually add TeleOp now. Yep, right here. Add TeleOp. Now, what we should do right now is first we first have to make our DC motors. What are DC motors? They're basically like motors that control the four wheels in our robots. Each motor will represent the position of the wheel, like such as now how I'm gonna make them DC motor. Okay. Now let's start with the upper left wheel. There's gonna be four wheels, so we have to name them all. DC motor, upper right, DC motor, lower left, DC motor, oh sorry, I didn't misspelled that, lower right. Okay. Now that we've made our four motors, we basically made the variables. We haven't actually connected them to the real world motors, but these are our program motors. That's where the init function comes in. So we will first grab a motor, let's say upper left, right? We're gonna do is equal to hardware map dot DC motor dot get, and we're gonna put, let's abbreviate it UL, meaning upper left. What this line basically does is basically communicated to your robot that this variable right here represents the DC motor that we named in our driver hub. You don't really have to worry about the driver hub right now. I'll make a lesson after this based on the driver hub, but this is how we named it in our driver hub, and our driver hub basically we give it the name. This is the name of our motor in the real world, and this is the name of the motor in our program. We're basically saying this variable is equal to this variable, so the real world motor is equal to the program motor. And that way we have a connection with the robot through the program. Now we basically, honestly, copy and paste this line and repeat all of this. Upper right, and let's see, right, and this changes to lower. Okay, basically, oh, sorry, we have to change these two to their corresponding names. LL. Okay, and then R. There it is. Now that we have this set up, something we haven't mentioned is in our physical robot, our left motors, when we try to move forwards, left motors go forwards. When we try to go forwards with the right motors, since they're technically flipped the other side, they go the opposite direction. They go, they're basically, they go they go clockwise instead of counterclockwise like the left motors. So if we don't reverse them, moving forward will basically make the robot rotate in circles, which of course we want to avoid. So what we're gonna do is just reverse the direction. So upper right, dot set, dot set, direction, DC motor, dot direction, dot reverse. Okay, so I'm gonna copy paste this because I don't want to take up much of y'all's time. Okay. Now that we've done this, our robot shouldn't be moving in circles when we try to go forward. Now the right motors will move exactly with the left motors in the same way when we try to move forwards. Okay. We already stated that the loop function looks for input, and we will basically get that input through a controller joystick. We will move the robot like how we move video game characters. So there are 3 movements a robot has to do. We're gonna represent them with 3 double variables. So double forwards, double strafe, and double turn. These are the 3 movements a robot has to perform. So, and we will basically set each movement to movement in a specific joystick axis in our game controller. So in this case, forward would be equals gamepad 1 dot left stick Y. So what this means is if we move it up and down, it will basically make this variable go up or go down. So now what we're gonna do is gamepad 1 dot left stick X. So strafing, basically, if we push the joystick in the X-axis, meaning left and right, the left joystick, it will basically move a robot left and right. Like if you're shifting left and right without turning or moving forwards or backwards. So now turning, it's still in gamepad 1. It's still in the same gamepad controller. Now it's gonna be in a different joystick, right stick X, because we don't want them to overlap with each other. We already used the Y and X axis in our left joystick, so that doesn't give us any room to add another movement in there. So we're forced to use the right joystick, which to me personally feels better. Now, moving on from that, these movements basically have their own respective axis, like the Y axis, their X axis, but these are on the left. The right joystick has its own axis, X axis too, so that's why we say that every movement has their own sort of personal axis. And they basically go from -1 all the way up to 1. -1 representing reverse power, basically moving backwards. So in this case, if we were going 1, that's basically moving forwards. If it was -1, forwards would be going backwards. That's why we named the forwards here. That's why we don't have to make a backwards variable, because forwards is both forwards and backwards variable. Strafe, we move to the right, that's positive. We strafe to the left or shift to the left, that's positive. Oh no, that's negative, sorry. If we shift to the right, that's positive. shifting left, negative, shifting right, positive. Like how in x-axis. You move left, that's negative, move right, that's positive. Same thing with our turn. With our turn, it's a little bit more complicated, but really it's the same principle. If we move our joystick to the right, we turn clockwise. If we move our joystick to the left, we turn counterclockwise. And it's as simple as that, but we represent that with an x-axis. We can't really move the joystick in circles because that's really inefficient and possibly hard to program too. Now, because of that, the joysticks, if we move our joystick halfway up, the robot's power would be 0.5. So let's say the left stick, I moved it halfway up, that's 0.5 power. So the motors would basically only move about 0.5 of their full power. And that's how joysticks work, really. They serve as like a sort of way to control the robot's power manually without having to basically, well, that's with manual input basically. Now, you can also set the maximum power, which we have to do right now, to our movements. And I would personally keep them at 1. But let's say your robot turns too fast, or your robot moves forwards and backwards way too fast. Well, you can basically set that movement down to 0.5, or 0.7, or 0.2, but that's really slow, I'm not gonna lie. You can also set it at a -1 power. Basically, if you move your joystick up, it's gonna go back. It's gonna go the opposite way, which that's not for me. If y'all want to do that, that's fine, but then again, I'm not used to that. So I would just put them all at maximum power for now. You can change them at your own taste whenever you want to. Now we're gonna get into kinematics, which sounds complicated but really isn't. In this section, in the engineering, I have a section about this in the engineering resources, and I will put a link down below to a video that I really recommend. So basically, search up GoBuilda mechanism movement diagram. It's an image that represents all of the sorts of movements and how the wheels should move based on if either positive or negative. We will basically calculate the movements of our motors based on the 3 movement variables that we made. You will use this image. It serves as a map of how we will add and subtract these variables as a sort of equation that we will form. Okay, let's take a look. Let's first start off with the lower left. We're gonna set the power of these motors, and once we set the power of these motors, we will calculate how they should. I'll just show you right now. Oops, sorry. Okay, lower left dot set power. We're basically gonna give all of our motors a power, but we're gonna calculate how much power we should give based on how we move the joysticks with these 3 variables. So if we look at our diagram and we look at a robot moving forwards, first we're gonna calculate forwards. The lower left wheel moving in the forwards movement is basically going up, arrow moving up, which will represent positive, and vice versa if it goes down, right? It meaning negative. So since it's going up, we just put forwards. We don't have to put a positive or negative sign, because if we don't put anything, that automatically means positive. So now we're moving on to our next movement, which is strafe. Now, strafe, if we look at our lower left wheel, we can see it pointing down, so that means minus strafe. Okay, and now if we look at turning clockwise, our lower left wheel is basically pointing upwards, which means plus turn. And we will basically do this for all of our motors. Y'all can do it on your own. Now that y'all have it, but me personally, I'll just do them real quick right now. I recommend y'all doing it by yourselves first. And this basically should be it. Let me just copy paste this. There it is. Right. Right. Okay, let me change these. All of the motors should be positive when going forwards. It's just this that is different for all of them. For these, it should be negative. Lower right should be positive. This one should be negative. Upper right, yeah. Okay, and this should be our full setup. This represents how our robot will calculate movement with forward, strafe, and turn. This is basically it for the basic fundamentals of how we can move a robot with a gamepad controller. And I hope this video served of any purpose to y'all starting out and learning robotics, FTC robotics specifically. This piece of code will basically serve you all of TeleOp. Not gonna lie, like y'all will be doing this every single year. Every single year. The code will look similar to this. The more you start knowing about how it works, the more different it's gonna look. And because of that, I can simplify this to about 5 lines of code. But that's for a more experienced level, of course. But I hope this served of any purpose to y'all, and thank you for watching, and thank you.